Hey, I'm Nicho Mercier, and this is my first demo video for Review Board as a part of UCOSP Fall 2017. My project is Message Bus. Message Bus provides a way for Review Board to make periodic message requests, which is essentially just getting updates for various pieces of data from the server, and then handling each of them appropriately. So instead of having a bunch of code making connections to the web API or whatever you need from the server, this provides a centralized way of doing it and makes all of the requests in one go. So you're not making 10 different requests to 10 different areas. You're making one request to one area with all the information needed to make all the other requests that you want. And they all happen at the same time. So all updates will happen at the same time interval and ultimately show up at the same time on the UI if that's what you're updating. This is just a bunch of test output that I'm using, and these are actually the requests made to the server, and this is the responses that they're getting. Just make note of the test here and the other here, because those are keys that are going to be used later when we talk about the message provider. But first, we want to talk about the message registry. So the message registry actually takes message providers or allows you to register message providers and query them using the message provider ID that each message provider has a unique one for. So when you come to the provider here, it's just a simple little base class that asks for an ID in the initializer and just provides you a function to get the message. And the getMessage function will essentially handle querying the web API or providing whatever data you're looking for. And we'll talk a bit more about that later when we look at the implementations right here. So a sample implementation uses the message provider ID test, and the getMessage just returns a string of the first message provider, which is consistent with what you're seeing in the console output here. And the other message provider is using the message provider ID other, and just returns a Unicode string of the current date time. So essentially the message provider just handles actually retrieving the data. Message bus interacts with the message providers by taking the request, which I'm going to show a sample of. Right now we don't have any way of parsing through or registering a message request on the client side yet. So right now I'm just passing them manually, again, test being one of the IDs and other being the other message provider ID. So message bus will take that JSON object, this is the JSON object that I'm talking about, and parse through that, and using the key it'll request the provider using that key. So this will, in the case of test, it'll return this guy, and in the case of other, it'll return this guy down here. And then it will call the getMessage function, passing the value as the parameter. So right now that's not really reflective of what you're seeing on the server because we're not actually using the value at all. But when you're querying the web API, you may want to use the value provided to actually get the data you need, or in whatever case you implement it. And then the data is being added to a dictionary, again being labeled by the provider or the message provider ID, and the response message, which is just received by the get message here. And then that gets returned back to the view that's responsible for actually passing the data along, and gets returned as a response to the server. So just quickly going through not the server, to the client, but quickly going through the client side of message bus, we have a backbone model here that implements a few functions such as register request, which again, like I said, we don't actually have message requests. I had an old test MB request down here that ultimately got ditched for a much better approach, but the object still stands just for testing. And what this lets you do is register a request and a desired time interval in which that request will be executed. That's in milliseconds. If there are no requests that currently exist, the ultimate interval that the request will be executed at will just be that, since there's no other requests competing. but if there are other requests, it'll actually choose the minimum one. So the highest frequency desired time interval will be used to execute the requests. Now, when it comes to actually loading the updates, there's one endpoint, and that's at /message bus right now. This could change, but for now, that's what I'm using. And yeah, so essentially just makes the request. It'll pass all the request data. In this case, again, it's just some default data that I put in, but ultimately that'll be parsed out from the registered requests. And that will query message bus on the server. And once we get the response, we go to the process updates function down here. And right now it doesn't actually have an implementation. It just logs the response, which is why you're seeing this. But in the future, it's going to take each request or take all the request data and pass it to a handler associated with the respective request that was made in the first place. So since we're using the message IDs or the message provider IDs as a key, we can find the different requests by the key and then just pass any response data to the handler for that request. This is all running on a timer, so this is where the timer comes into play. After the request is done, it'll see if the timer is still running. That's just from a Boolean flag called isRunning. And if it is still running, it'll essentially call the load updates again after a certain period of time. That certain period of time is the time interval that we chose as discussed above or before. And here are just some simple start-stop functions for the timer. Yeah, so when I execute my test, we'll see that right now these requests are coming in at roughly every 2 seconds, and that's because that's what I did in my test here. If I were to change this to, say, 500 milliseconds, we'll see that these will start coming in a lot quicker once that reloads. There you go. So substantially quicker, and you'll see, even though I registered one for 300 milliseconds or 3000 milliseconds here, the 500 one is the one that gets chosen. Yep, so that basically summarizes what I have done right now, and the future of message bus will essentially be to implement the remaining basic functionality, which will be handling the responses on the client side and handling better handling the requests on the server side. And ultimately I want to work in some caching, so if values haven't changed, there's no need to return them. So there's going to be a little system for that. And yeah, that's about it. Thanks.